1, 2, 3, pour. Just fill it to the top. Try to cover it the best that you can, and put the beakers to the side, and we're off to the races.
Right here, bro.
All right. This, of course, is for a modest prize for your group. Playing for such a modest prize, you probably don't, maybe not even want it. Okay.
How modest?
What's the prize?
It's modest.
Even if it's a pencil. I need pencils.
There you go.
Is it food related?
Oh, can it be food related?
Why would any teenager want food?
Do you still have M&Ms in your fridge?
Probably.
Can we have them? Well, just brush it off.
Maybe. If you earn them.
If we
Hi,
all,
Karen. Voice crack.
if we're all nice
I'm gonna
together,
lace them with
and then
phenolphthalein.
pass it on their purse.
Tasty.
I'd rather.
Isn't that a laxative?
Put it in, put it in.
All right, who's got an early lead here?
Here, here,
Oh, the heart's looking good.
here.
Heart's looking good.
Sophia, here.
By the way, it's on the big screen here. Looks like the heart's doing pretty good.
Ours is going from the inside.
Triangle's looking good too, whatever this is.
Oh, yeah, pick one.
But remember, this is not going to be just because it diffused the one. First, you gotta consider the mass. We're looking for the highest mass to time ratio. That's the winner. So what's going to happen, party people, is I'm going to post this video.
Oh, I thought we were going.
You're going to run the video back to get the time code to figure out exactly what time it went clear.
Wait, no.
And my friends,
Wait, it was different.
you're going to put the names of the teams in here.
I swear.
Because you can, at least the initials, you can see that in the video.
So it was the same.
Wait, no.
Stop
but-
talking. So, your homework is, this video is gonna be posted, you saw last night's video, and you're gonna play it, you just scrub through to see what the time code is. What the time code is, you can use that for the time it took to completely diffuse out. And you're gonna write that time here. The mass is written, should be on the bottom part, write the mass here for each of these. We're gonna have 5 teams, so you don't have anything here. Please put a name to the team or the initials that you can best identify. So write the mass of these teams, write the time. I want you to calculate the mass to time ratio for all of them. You guys will walk in tomorrow knowing the winner. And then distribution of prizes will probably be Friday. Okay? Remember, it's a modest prize. Okay? So that's part of your homework. The other part of your homework, you have a small form. It's not much. But I
swear
on
it's
today's work also. I need you to give yourself some effort on the FRQ. This is how
low
the
mass.
AP
She thought you
takes
wanted
these
the
what?
least surface area
Takes
possible.
these concepts and puts it to
No,
a
you
scheme.
double the
You have to unravel.
What?
Wait, no, but the ratio, he said different ratio.
Because
it's such a big
it's such a big mass.
And it's
Am I
not
going
going to take
crazy?
double the time
Yeah,
because it's
I
almost
think you're just
all.
really
Yeah.
sleep
So I
deprived. No, but like the arrows were different. I swear, Abby, the arrows were different. The arrows were different. They were different. I swear. It was sweet. It was, the time was up.
Heart's looking good. But this one right here is cooking right here. Now the one that has the highest mass that holds on to have a relatively good fast rate is probably a winner because ours is hollow too, so in the inside is
Going No, but Abby, I cannot
so
be
you don't have to be
That's not.
contender.
It was different. It was different. No, Abby, it was different. I swear it was different. It was different.
You got a trophy, everyone gets a trophy for breathing. Okay, sorry. Everybody in the orchestra will be first chair for every instrument. How does that work?
It was definitely like Sophia.
Everybody takes a lead to play. Every scene is a new lead.
Every scene, I didn't
Unfortunately, this is what goes.
I replied to the story because it was
Yeah, this one right here is looking like it's made in best. But because it's hollow, it doesn't have a lot of mass. Yeah, that's a big mass.
I thought it was
5.48.
Yes. Is that your pouch? No.
What is this right here? A triangle?
Yeah.
Okay. This is similar to, this is a rectangle. This looks like it's similar mass but faster time. This looks like it's, All right, guys. Have a unbelievable day.
Bye, Mr. Grosky. Yo, Zion, I'm about to go devour this crap. No, I didn't. Bye, Mr. Grosky. Let me see it. Christian! What happened, Sal? Are you going to? They're just gonna follow me.
Well, think about a cell in the body.
Bye.
I like that you laugh.
Bye, thank you.
Don't think you're funny.
Hollow cells have
Abby.
having concave cell. And, yeah, exactly. What arrows?
She thought she wanted a little surface. Bye, thank you.
Bye, Mr. Grosky.
Look at ours on mine. For the size, it's the one in the bottom corner. That one, yeah.
Ours is the heart. I'm gonna be so honest, we just did it because it looked cute.
There's a link to a live feed, so no, just kidding. No one really cares. Huh?
It's gonna be done in like 10 minutes, so like.
Which one do you think is coming in last?
The rectangle. Oh, wait a minute. There's a cube. There's a cubic. The rectangle. The two top ones to the right are.
These two?
Yeah, they're lagging.
You should flip the camera off, Cameron.
Huh?
You flip the camera off.
I put 2 fingers up.
But it looked different.
Yeah, it did.
Wait, that part is like not underwater. Is it? I don't know.
Well, we'll see. All right.
Yeah, that little top part, but like.
It'll still diffuse.
Wait, somebody complete the heart.
Hi, thank you. Be smart.
Yeah, we have a little like tip of the iceberg.
Yeah, it's still diffused. I think it's still. Yeah. Yeah, sure can.
Costume design cell, that's so cool.
They're playing for modest prize.
Oh, should we
High
put
surface to volume ratio.
Should we put these in the bedroom?
If you're done, yes, please.
Oh,
Or,
that's
okay.
I love your shirt.
You need to,
Can you go to the staff, please?
yeah.
Thank you.
Or, oh, really? Oh, that's impressive. Oh, okay. I think it's because that form I have to do it by hand. Oh, which form was it? One was that one? Okay, well you did it, so all right. That shows ingenuity.
There you go.
All right. Too much light. Oof. That's better. Okay, so we're taking out our labs. You go, Lily. Oh yeah, that's gonna really work, I know. There'd be so much focus being outside. Would you like me more if you go outside?
Yeah.
Okay, so we're not, okay? It's better if you guys hate me until the end.
But I'll be happier because I'll have like serotonin. Yeah. More dopamine.
Vitamin D.
Yeah.
Yeah, well, just drink milk.
Oh, yeah.
Sit next to a UV bulb. That's where the theater people get their vitamin D. Stage lighting. They're never outside. Okay, everyone's got those. Hey, Fernando, how's it going, kid? All right, I'm tall, I guess. Okay, we're gonna need a separate piece of paper. If you don't have one, I can give you one. Because we're gonna add to this lab. I should put a blank piece of paper at the end at some point. I'll do that, but boy, I am out of my mind. This should be two different AP classes. Yeah. As far as I know, yes. Yes, as far as I know, I am. But only for freshmen. I actually have one senior, which is kind of cool. So, did you? Yeah. So, AP Bio. They haven't told me otherwise. They haven't said so. I'm guessing. Who needs a piece of paper? Who still requires a piece of paper? Ooh. Okay, here we go. Thank you. Yep. All right. So this is the last piece of your lab. Don't worry about any of those conclusion questions. You're going to add this to your lab. So what we're going to do is we're going to write the reactions, and we're going to kind of work on the lab a little bit. And so we're going to apply what we learned from last night to your lab right now, and then I'm going to teach you why it works. Okay, and something new. So you learned a skill last night that delta H's of reactions are interconnected. Somehow there's some kind of interconnectivity of delta H's of reactions that when canceled out to get the overall reaction, we can get an overall delta H. That's an important, it's called Hess's law, the interconnectivity of these. Is it entropy? No, it's enthalpy, delta H, okay? So what I want to do here is I'm going to rewrite those three reactions, okay? So we had reaction 1 was hydrochloric acid and sodium hydroxide. I'm going to write the net ion. Hydrochloric acid is a strong acid, so I'm going to have H plus. And NaOH is a strong base, so Na plus is going to spectate, and that's going to give me a hydroxide, and that's going to make, of course, water. That's the net ion for the first reaction, net ion reaction, which is a skill that we have to have. We've been writing them for a long time, we just haven't done them for a while. I got rid of the sodium because it's always soluble, it's not a conjugate base, it doesn't ionize water, remember that stuff? I got rid of chlorine for the same reason. Okay, someone give me their delta H for this reaction. So how about, you guys, what'd you guys get for the delta H of the first reaction? Negative 60, negative 50.
Negative 58.1.
58.1, we'll say there. The unit, of course, is lowercase k, uppercase J, that's kilojoule, and that's going to be mole, and we're going to say reaction, mole per reaction, okay? Okay, the second reaction, that was ammonium chloride. Or what was the second reaction? It was
Ammonium chloride and NaOH.
NaOH. So NaOH
Yes.
is the Na plus is a spectator, so we have a hydroxide. And the ammonium chloride is going to dissociate into NH4 plus. You say, what happens to the chlorine? Well, it's going to spectate, I think. So what's going to by the way, these are both acid-base reactions. What's going to happen is this is gonna donate an H to the hydroxide. Well, the hydroxide being a strong base is gonna rip an H off the weak acid, so it's gonna make water. And it's gonna make ammonia, NH3, stinky. Yesterday, chemistry stunk, maybe most days.
Mr. Goffey?
Yeah.
Is NH4, is it plus or minus?
Oh, it's plus, sorry. I'll make the plus bigger. Okay. It's holding on to an extra proton, okay? I'm just writing a net ion equation, not trying to confuse you. Okay. Now, the third reaction, I want you to put a line between those two. Because just like last night, these first two reactions, guess what? Can be manipulated to get the third reaction. Ooh, ooh, ooh. Rising action, oh my God, something different, didn't expect it. Now, the overall, so the third reaction was ammonia, right? So we had NH3. Hydrochloric acid is a strong acid, so H plus and Cl dissociate. Cl doesn't do anything in water, and it's always soluble, so it's gonna spectate, so really it's just an H plus. And this is going to make NH4 plus. You can't see it, all right? It's plus. All right. So guys, what did you guys get for your delta H of this reaction here?
Negative 7.9.
7.95, so 7 point. Of course, because everyone had a different thermometer that might have been calibrated slightly different. So if you're measuring the change in temperature, it's okay. So yeah, so 7.95 you said? I'm gonna do that right there. And the unit is little k, big J for Henry Prescott Joule, mole per reaction. Mole of each reaction. Okay, now, let's go find our first theoretical value. So let's go find our theoretical value. So what we're going to do here is we're going to solve for the theoretical, or just Theo. Say hi to Theo for me. Right? Theoretical.
Oh yeah, we're FaceTiming tonight.
All right. Said I mentioned your name today.
Okay.
Not really, but I said
He's always
theoretical.
like, so, like, does anyone remember me? Like, does anyone say, like,
You have to say no. Anyone ever asked those kind of questions in my family? No one remembered you. Even if they did, you always gotta close the door on that. That's how I grew up. Do I look okay in this? Oh no. Even if you did, you don't ever ask those questions in our house. Is this like my teeth? Definitely not. Okay? What a great way to, you may say that was a terrible way to grow up. It was a great way to grow up. Because you can take criticism, you know, you learn when people try and manipulate you. So theoretical. Okay, so what we're going to do is the same thing we did last night. There's an interconnectivity of delta H's. I'm going to explain why, but here's the skill. Just so happened the three reactions, the first two, can be manipulated to get the overall. So this is the overall reaction. And I know that you have a delta H for it. I want to, okay, compare it to the theoretical that we get by manipulation by using your data. So, any case, if I want to manipulate it to this one, I need ammonia, NH3, to be by itself. I see ammonia on this side. Already, I know that I'm going to have to flip this reaction because I need it to cancel out. And I need the right what? Reactants on the right side. Look what NH4 plus has to be, okay? Oh, I need that over there too. Where's H plus? Oh, that's already here, so this one's okay. So I have to flip this one. Now, when I flip this one, what happens to the sign? If I'm exothermic and releasing energy in this direction, I'm absorbing in this direction, so I have to flip this. This becomes positive, okay? Now, let's just see if that works out, because last night sometimes you had to multiply by 2. Or 3 or and a half, and whatever you do to the individual reactions to get the overall, you do to the individual delta H's. That was the skill. So I'm going to flip this around. I'm going to write it in different color. NH3 plus water gives me NH4 plus hydroxide. I'm not gonna kind of consider this anymore because I flipped it. I know last night I told you to rewrite it. It really is helpful to rewrite them. I just don't have the space here. So I'm doing that. But I reminded myself that I flipped it and I changed the sign. Okay, let's see if this works. I have NH3, right? Okay. Notice there's no water in my overall, but I have a water here. So it better cancel out, and of course it does. I'm taking in a water here. I'm producing it, so there's no net change of water. Okay, there's no hydroxides here either, so the hydroxides better cancel, and they do. Okay, and so when I'm done doing this, I should only have ammonia, NH3 on one side, and H plus, I do. And I should only have NH4 plus left on that side, and I know I set this up. So after my manipulations, in this case, I only flipped the second, all right? So now I'm just gonna add them together. Remember, I flipped this one, so I changed the sign. If I had to multiply like last night by 2 or a half, I do that to this delta H to then add them. Because delta H's are interconnected by something. That's something I'm gonna teach you today. So for you guys, it'd be negative 58.1, in this case, plus 7.95. And so, party people, these guys, you're going to get a different number because you have different data, but they're theoretical based upon using Hess's law, the interconnectivity of delta H's. They get negative 50.15, and that's lowercase k, uppercase J, and that's mole of reaction, okay? And that's what they should get. Your value is different because you got two numbers here, but you're flipping the sign here and adding them together. This is last night's skill, not hard, okay? Now, you're gonna do now, this is all part of the last part. So then the first part, you're gonna do a percent error. You're going to use this number as your theoretical. What did you guys get, okay, for your experimental value of this through calorimetry?
Negative 52.7.
Okay, now there's something very important. This was their experimental. Okay? And that's the theoretical. So what's easy to do to do percent error, get rid of the negative signs. You're just gonna look how different these numbers are to each other. So the negative signs will confuse you. Even though this experimental, you've measured more releasing of heat, okay, than theoretical. Now, generally speaking, although it didn't come out in this spec, did anyone find their experimental to be under the theoretical? Did anyone get that? Did anyone have less heat released? Did everyone have more heat released in their experimental? They measured water with a greater temperature change.
You're not looking at it through negative.
Yeah, so they got, hey, so way to make this simple for yourself. The negative is a direction. So the amount of heat is that there was 50.15 joules per mole released. There was 52.7. They got more energy released when they did the calorimetry than they did when they used these values, okay? Did anyone get less energy released in their calorimetry compared to this value here? Okay, just interesting. So do a percent error there. Now, you're gonna do a second percent error. Yeah, so percent error is experimental, which is the measured, minus the theoretical, divided by the theoretical times 100. So I don't want you to take up time for that now. Second thing is another percent error. You're going to use today's lessons that I'm going to teach you another skill, or at least part of it tonight. Tonight's skill set, you're going to be able to figure out the delta H of this reaction directly through the tablature that I gave you. And I want you to compare that to your experimental. Now, honestly, think about this for a second. The second percent of error is definitely a better strength of accuracy. Remember, percent errors measure how close your values are to the known, correct? The first one is kind of not the best way to do business because I'm basing it upon what? I'm building a theoretical based on what? Measured values, okay? But what I want to do, the second one is take your experimental and we're going to figure out these values based upon known directly. So we're going to do a second one. We'll probably do that a little bit today. So now, I want to spend the rest of today teaching you why this works. Because you did it, you can be a robot, oh, balance the reaction, okay, whatever I do. The skill set is not difficult. Understanding why can help you navigate problems where you don't see the answer. I'm here to help you understand why you do it. And to me, it's the most exciting thing that I could ever do, okay? So, let's continue with our, and again, so much more I'd love to do in terms of defining enthalpy. And I probably will spend some time showing how enthalpy shows up. But we know right now enthalpy is a state function. Q is not. If we have constant pressure calorimetry, the Q does equal the delta H as long as you convert that heat with the right sign and divide it into the moles that actually gets reacted. If you notice something, we used a 2 molar solution for all of the reactants. Therefore, if you figure out the energy per mole, we were figuring out per one of these reactants. Because they all have a coefficient of 1, okay, I was dividing by how much of this or this